Welcome, my friends. In this video, I'll be beginning my discussion of Chapter 6, Analysis of Two Quantitative Variables. In this video, I'll be discussing Section 6.1, Scatterplots. A scatterplot is built on data that looks something like this, where you have two variables collected for each individual. So, for example, the first individual had a value of 39 for the x variable and a value of 50 for the y variable. And person 2 had a 27 for the x variable and a 41 for the y variable, etc. for all the different individuals. And the most common way to graphically display this information would be with a scatterplot that looks something like this. We have the x variable, which is traditionally the independent or explanatory variable on the horizontal axis, and we have the y variable, which is the dependent or the response variable on the vertical axis. And we typically set this up in a way such that we think that the x variable may have some kind of causal or maybe influence or some kind of relationship with the y variable. And we're just plotting each of the pairs onto the graph. So for example, we have the point 39, 50. So we can go over 39 and we can go up 50 and there's a point there. Or we have 27, 41. So we can go 27 and we can go up 41, and then we're just plotting all of these as points. Now we are not connecting the dots here, although in some cases we may draw a straight line to kind of fit the pattern of a scatterplot. So the definition of a scatterplot that we're using is that it's going to model the relationship between quantitative, explanatory, and response variables with data pairs x, y plotted as points on a grid. Now I'm going to mention at this point that the TI-84 calculator can create a scatterplot, so let me just show you this. If you go into your stat list and you press enter, and you clear out your list, and then you plug in all of these numbers into your first two lists, which I already have right here. If you press the second key, and then y equals, and you go into the very first plot, you have the option here. Well, first of all, make sure that it's on, and then you have the option here to choose a number of different plots, and the first one right here, which is the scatter plot, and then you can press zoom and 9, and then that will show you the picture of the scatter plot, which is the same one that we're seeing here. So let's look at another example here with some actual variables. It says a cafe at a local university sells both coffees and sodas, and the number of coffees and sodas sold each day of the spring semester is displayed on this scatter plot. So we have the number of coffees sold as the number of sodas sold in each day, right, throughout this semester. And from the scatter plot, we can tell a number of different things about the two variables, either individually or kind of in relation to each other. So here are a couple of observations that I had. The number of coffees sold in a day ranges anywhere from 3 to about 48. So like the smallest value is down here, apparently it's around 3. And then the highest value is way over here, it's about 48, right? The number of sodas sold in a day ranges from a minimum of about 11, maybe this point right here, all the way up to a maximum of about 55, which is this point up here. Now there is a little bit of, you could say, like a downward trend to this this chart here. When we move towards more coffee sold, move to the right in the horizontal axis, the sodas tend to be a little bit less sodas sold. So the more coffee sold, the less sodas tend to be sold, but it's not really that strong of a relationship. So that's what I'm saying here. As the number of coffees sold increases, the number of sodas sold tends to decrease. And so we would say that there is a relationship between these two variables, but it's not a particularly strong relationship, right? In other words, we wouldn't really be able to reliably predict how many sodas would be sold based on the number of coffees sold. But we could say that in general, when there are more coffees sold, there tend to be a little bit less sodas sold. Okay, in general, there are 5 questions you should be asking yourself about any scatter plot to kind of analyze it and get information out of it. So the first one is, number 1, does the scatter plot show any relationship at all between your two variables? So in some cases, you could just have kind of just like a mess of points that really don't have any pattern whatsoever, no shape, not really telling you anything. And at that point, you can just say there's no relationship and it's not really worth asking any other questions about the scatter plot. These don't seem to be variables that are related in any way. But if there is some kind of relation, then we can ask some additional questions. And number 2 is, what type of relationship is there between the two variables? The most common is going to be what we call a linear relationship or a straight line relationship. Or in some cases, there could be some sort of maybe curve, maybe like an exponential pattern, or possibly even like a parabola, like a U-shaped type thing. But the most common one that we're going to see, and the one that we're going to focus on the most in this class, is going to be the linear or straight line type relationship. We also want to discuss what the direction of the relationship is. So generally, the two types of directions we could have are basically like a positive direction or a negative direction. The easiest way to show that is just based on the scatter plot. So this would be like a negative direction, you could say, where as one variable increases, the other one tends to decrease. And the one we had on the previous slide was more of we call this like a positive relationship or a positive direction. As one variable increases, the other one also tends to increase. So that's what we mean here when we say, what is the direction of the relationship? Do they tend to increase together? That'd be like a positive relationship, or are they going in opposite directions? We call that like a negative relationship. Or is the relationship more complicated? Maybe it's not really as straightforward, and then you would also state that for this part. 4, how strong is the relationship? Do most of the points follow that pattern, or is there quite a bit of variability, right? So if all the points are very, very, very strict and kind of narrow, really fitting that maybe like a straight line to the dots, then you would say it's a very strong relationship. And if it's a little bit more scattered, kind of like this one, we would say maybe it's not quite as strong of a relationship. And finally, we would want to identify any unusual points, any outliers if there were any. And there are a number of different types of outliers when it comes to scatter plots, and we'll talk about those in a future slide here. So here is an example of a scatter plot that has both x and y on it. And here we can go ahead and answer some questions about this. So the first question is, does a scatter plot show a relationship between x and y? And then if no, we will stop here. So if we look at this scatter plot, I would probably say there is not really much of a relationship going on here, right? As we move further to the right in terms of x, there's not really a reliable pattern in any way for y. So I'd say there's no identifiable relationship between x and y shown in this scatter plot. So therefore, it's not really worth it to ask any of the future questions because those all depend on having some sort of relationship in the first place. So this is really where we would stop with this graph. We would say, nah, there's not really anything else we can do with this one. Let's look at another one. So this one does have an identifiable pattern here. It looks like we have some sort of relationship. So number 1, does the scatter plot show a relationship between our variables? Yes, that's all we would really have to say for number 1. There is some sort of relationship. Number 2 says, what type of relationship is there between the two variables? And is it linear, or would a curve fit the scatter plot better? Well, in this case, a straight line does seem to fit those dots pretty well, right? If we drew a straight line through this, it wouldn't go through all the dots, but it is following the pattern of the dots. So we would say, yes, a straight line would fit the scatter plot well, or we could say this is what we call a linear relationship. Next, what is the direction of the relationship? Well, the direction is, as one variable increases, the other one also tends to increase. And sometimes we would call this a positive relationship. Positive in terms of scatter plots means the two variables go together, and negative actually means they go in the opposite direction. But in this case, we would say as x increases, y tends to increase as well, or we could say it's a positive relationship. Next, how strong is the relationship? So we would say most of the points fit that pattern pretty well. So we could say that it's maybe a moderate to strong relationship. The straight line doesn't fit the dots, exactly, but they all seem to fit that pattern, pretty well. So we'd say it's a moderate to strong relationship. Are there any unusual points or outliers? In this case, there are no unusual or outlier points. So these are the 5 questions you should be prepared to answer with relation to any scatter plot. Now, when it comes to outliers, scatter plots can have outliers with respect to x, y, or both, or from just the general pattern of the scatter plot. So here's a couple of different examples of outliers and how they could kind of affect the graph, or how they might look on the graph, right? So in this case, it looks like we have actually kind of like an outlier in terms of both x and y, right? This one's like much higher than any of the other x's, and it's also much higher than any of the y's. So this would be an outlier in terms of both x and y, but not in terms of the pattern. It still kind of fits the pattern pretty well. This one is an outlier in terms of y. It's much lower than any of the other y's, but it's really in line with all the x's, right? It's still within line of the x's. It's also an outlier in terms of the pattern. It doesn't really fit the pattern at all either. This one here is an outlier in terms of x. It's a lot higher than the other x's, but it's not in terms of y. But again, it is in terms of pattern. It doesn't really fit the pattern. And finally, this one is an outlier in terms of both x and y and pattern. So it's kind of everything together. And some of the things we're going to do later in terms of these scatter plots, such as linear regression, are really affected quite a bit by the outliers. So you really always want to graph this type of data first before you do analysis. so you can catch possible outliers, because you know that those are going to reliably, in many cases, affect the analysis in one way or another. And we'll talk more about that in future videos. All right, that's all I had to talk about in this video, so I will see you in the next one.